Hello and welcome to Team 4's project presentation on predicting loss ratios for auto insurance portfolios. Our team members are Aditya Kamble, Erma Hadar, Niraj Bista, and I'm Mike Teague. First, we'll introduce our project and the background behind it. We'll then briefly discuss our employment of domain knowledge, as well as our use of exploratory data analysis techniques. We'll also share our methods used during data preprocessing, followed by an explanation of the modeling techniques we employed. And finally, we'll share our overall evaluation and conclusions for the project. The problem which our project seeks to resolve is one which is very common in the insurance industry, and that is that 50% of all policies can be mispriced by more or less than 10%, all the way up to 50%. So as you can imagine, this can have implications on the profitability of an insurance provider. Our project was provided two data sets for training and testing. Our training data set consisted of around 400,000 input samples of auto insurance policies. This data included 64 input features such as vehicle make year, vehicle performance, usage, miles to work, etc. Additionally, these features were categorical in nature for the most part. Our testing data set, however, consisted of 330 policy portfolios, with each portfolio containing at least 1,000 policies. These included the same features as above with the exception of loss amount among others. The objective of our project was to first predict the missing loss amounts in the testing data as just mentioned. Secondly, we used that prediction to in turn calculate the loss ratio and natural logarithms for the portfolios in our testing data set. This brings us to the overall goal of our project, and that is to create a competitive advantage for an insurance provider by developing a model or models capable of predicting the loss ratios of policy portfolios, which will in turn enable them to more accurately assess the overall risk of a given portfolio, as well as make better informed decisions on premium rates. Finally, shown here is an overview of our project workflow, which we'll be discussing in detail later. We began our project by further investigating each of the included features in our data sets to gain a better understanding of the information they provided. We then documented this information and utilized this resource to track the specific features used during our various modeling processes. Our next step was to conduct exploratory data analysis on our data. To accomplish this, we utilized four tools. The histogram provided a comparison of the distribution of each feature. For example, this demonstrates that our data represents a large amount of middle-aged drivers based on the driver max age feature. Next, we used the pair plot where we compared the relationship of each feature to our target variable, in this case the loss amount. We used the correlation matrix to compare our features with each other. For example, this told us that the driver minimum age feature is closely related to the total teenage drivers feature. And lastly, we used the bar chart comparisons to evaluate the various occurrences within each feature. After completion of our exploratory data analysis, we then began our data preprocessing, where we evaluated factors of missing data, imputations, scaling, as well as other implementations. We first performed data cleaning by dropping all null values, removing trailing white spaces, and eliminating features which consisted of more than 80% of unknown values. We then conducted our data transformations by merging existing features into new features. As an example, we merged the various age group features into fewer features. Additionally, we organized the training set into portfolios using a similar approach to that used for the testing data set. Once our data preparations were complete, we attempted both linear and tree-based modeling techniques. During this process, we discovered that tree-based modeling techniques perform better due to the categorical nature of our features. Finally, for our evaluation methods, we first split our training portfolios into training and holdout sets. We then calculated the mean absolute error on these new splits. Loss amounts in our testing portfolios were then predicted using our model. These predictions were then used to calculate the loss ratio and corresponding natural logarithm of the portfolios themselves. And finally, these values were then submitted on Kaggle, which provided a rank based on the mean absolute error of our submissions. As can be seen here, the mean absolute error of our submissions on Kaggle improved significantly over the duration of our project, and our best scores fell below the baseline of the public leaderboard. In conclusion, we believe that statistical modeling offers a unique competitive advantage in many industries, but in particular the insurance industry. We feel that this project has exemplified this advantage in a compelling way by further demonstrating the enhanced capabilities of analyzing risk and profitability using data science. On behalf of our team, we hope you've enjoyed our presentation and found it insightful. Thank you for watching.